Good day. Today, as you have seen, we will be discussing about the belt drives. So, this is lecture number 30. Now, normally we call these belt drives also by another name called flexible machine elements, and these flexible machine elements are normally used for varied industrial applications. If you look at the board, just see that these flexible machine elements are used in conveying systems, used for transmission of power, replacement of rigid type power transmission system. What this means? This means, say, a gear drive is also a power transmission system. So, in case of instead of a gear drive, we can also think of this type of belt transmission system. Now, it has got an inherent advantage in the sense that it can take up a good amount of shock and vibration absorbing capacity. It has got a very good shock and vibration absorbing capacity, what I mean to say, and it can take care of some degree of misalignment. And for these reasons, flexible machine elements are widely used in industrial applications. As a matter of fact, normally the power transmission can be carried out over a longer distance in comparison to other transmission systems. This is also an added advantage for the flexible machine elements. So, which we commonly call as the belt drives. Here we consider as far as flexible machine elements are concerned only the drives belonging to flat belt drive and the V belt drives, although we have some other drives like rope drive and timer belt drives, etc., but we are not considering those aspects. If you say once again, that was the board, it is a common type of transmission belt transmission system is as shown in this figure. This you can see, this is one pulley, this is another pulley. This particular pulley we call it as a smaller pulley and this is a larger pulley, as you can see from the figure also. And here is this particular one is a belt which is wrapped over here. Now, in this case what is happening, that if we consider this smaller pulley to be the driving one, then this driving pulley will be transmitting a motion to this particular belt, and the motion of this belt in turn will give a rotation to this pulley, and thus the transmission of power from the driving to the driven pulley is accomplished. In this case, this figure, what has been denoted over here is called an open belt drive system, and some of the nomenclatures for the open belt drive systems are as follows. DL is the diameter of larger pulleys, this one, then DS diameter of the smaller pulley, this is the diameter of the smaller pulley, then we are having alpha L, that is the angle of wrap of the larger pulley. So, what is this one? You can see when the belt is going over this one. So, this distance from here to here, there is a contact that is taking place. Okay. From here to here, a contact is taking place over the pulley, and that angle we are calling as an alpha L. And similar situation you can see. Now, this is the angle which is coming in contact with the smaller pulley. So, from the geometry we can simply say that the total amount of angle excess of this 180 degree is in the similar fashion, it will be the lesser over here for the smaller pulley, and C is the center distance between these two pulleys that has been shown over here. Now, in this case the simple formulas for this alpha L, alpha H, etc., are like this. So, angle of wrap for the larger pulley is 180 degree plus this one is the 2 beta, while this is one angle and this side is an angle. So, this is plus 2 beta. In the similar fashion, alpha s is given by 180 minus of this angle and this angle, which is again coming out to be as 2 beta, and L 0 is the pi by 2 dl plus ds plus 2 c. This is the belt length, what we call this is the belt length, means what is this entire belt length is coming out to be in this fashion. Now, here this beta angle, what has been shown over here, this beta angle is nothing but sine inverse dl minus ds by 2c. Could this one as bracketed term. So, this is the value of the angle beta, which you can easily verify from the simple geometry. Now, once we consider this type of drive as an open belt drive, then we find out that this one is the cross belt drive. You can see this particular one is a cross belt drive. Now, here in this case, if you look for the open belt drive, one situation you can see is that whenever you are considering this open belt drive, then the direction of rotation of the pulley, if we consider in this direction, then the other pulley also moves in the same direction, means if it is rotating from the top in an anti-clockwise rotation, then this is also having an anti-clockwise rotation. And secondly, if we go for the cross belt drive, you can see the direction of rotation is changing if it is in the anti-clockwise, and this gives an clockwise rotation. Now, in this case, here in the both the cases the angle beta is subtending on these two sides. So, therefore, the angle of wrap alpha L is equals to alpha s. This is alpha s and this is alpha L, both are the same in this case, and it is given as 180 degree plus 2 beta. And in the similar manner, the length of the belt for the cross belt drive comes out to be this one. This is the entire length of the belt for the cross belt drive, and that is given by this formula pi by 2 dl plus ds plus 2 c plus dl plus ds by 2 whole square 4 c. And here you can see the beta angle, what was defined earlier, has got little difference, which also can be seen from this geometry, which comes out to be sine inverse dl plus ds by 2 c. So, if we compare once again the expression of the open belt drive, then you can see that this is the length of this one. I think just one second, this is the length of the belt in open drive dl, and so there is a difference is in plus and minus, but here you can see the angle of wrap is little different from what we have seen for the cross belt drive. Now, it is important in this case that what are the belt tensions. Now, one has to know that these drives, that means these belt drives are primarily runs on the friction principle, means the friction between the belt and the pulley is responsible for transmitting power from one pulley to the other pulley, or in other words, the driving pulley will drive or keep a motion to the belt, and the motion of the belt will be transmitted to the driven pulley, and all these transmissions are done through the friction. Now, the situation comes like that, due to the presence of friction between the pulley and the belt surfaces, the tension on the both sides of the pulley are not equal. One will be higher and other will be lower. So, it is important that one has to identify onto a pulley and belt system that which one is an higher tension side and which one will be the lower tension side. Here this figure on the board represents a simple method by how you can find out the belt tensions. Just you look at this one, you can see for this is the one which we call as a driving pulley. That means, this pulley is attached to a prime mover or some machine which is giving an motion to this pulley, okay, some motor or some IC engine or something like that is there, which is giving an power to this particular pulley, and the belt has got tensions, namely T1 and other one is T2. Now, the simple idea of the friction will suggest in this particular manner. Now, we can see, just for the purpose of explanation, this belt has been drawn little away from the pulley. Actually, it will be touching, but just for the explanation purpose we are putting it little away from the pulley. So, when this pulley starts rotating, then what is the idea? The simple nature will say that this belt will employ a friction force onto the pulley in the direction as shown over here. So, this particular friction onto the pulley will be in such a way that it will try to oppose the motion of the pulley. So, it will be in this direction. So, thereby the friction on the belt will be on the other direction. So, other direction means opposite to this particular direction. So, you can see that this particular friction onto the belt will do what? It will just push the belt in this direction, thus creating a motion of the belt as shown by this particular arrow. So, if we just look at this particular belt, you can see that there is a T2 that is acting on this side, there is a T1 acting on this side, and the friction force is acting onto this side. So, simple equilibrium of the belt suggests that this T1 should be higher than T2. So, that has been mentioned over here, T1 is higher than T2. Now, onwards we will always refer in this particular discussion that T1 is the tight side and T2 is called the slack side. That means, this is T1 is higher tension side and T2 is lower tension side. Now, when we consider this fact that T1 is a tight side and the T2 is a slack side, in the similar manner we call this is the tight side of the belt and this is the slack side of the belt. Now, you can see in this particular one that the slack side or the pulley drive has been kept onto the upward side, onto the upper side. Now, this has got an implication. The implication is that you will be learning very soon that if you are having an belt drive, then what is happening, that if you are putting a belt, the tight side means something like this is going and slack side means exaggerated something like this. So, this is a that what we are calling as the slack and this we call as a tight. Now, due to this slackness, what will happen? You can see the angle of contact or angle of wrap is coming out to be more. So, that is the reason what is happening, that if there is a more contact, there will be, it will be shown also mathematically after some time, that there will be more contact, means there will be more friction acting onto this belt surface, and thereby the power transmission will be better in this particular case. On the other hand, if it is other way round, that means if we consider the slack side to be on the lower side and the tight side to be on the upper side, you understand that similar situation will be can be drawn. So, this is the tight and this is the slack. So, you can see in the exaggerated figure, obviously the angle of wrap is decreasing, thereby the power transmission capacity will be decreasing. So, you please keep in mind that whenever you are trying to design a belt drive, then always keep the tight side onto the top surface and I am extremely sorry, the tight side onto the lower side and the slack side onto the upper surface. This is true for the what we call when we are having the horizontal transmission, but here I would like to mention that this belt drives, particularly when you will be talking about the V belt drives, you will see that V belt drives need not to be always in the horizontal direction, and it can be seen in several applications that any orientation of the pulley center line axis can have during for a belt drive system to run. But normally when we consider about the flat belt drive, in majority of the cases it will be in a horizontal manner. However, this suggests one important situation is that we will be always keeping the slack side onto the top and the tight side onto the bottom surface. Now, continuing our discussion onto this belt tensions, once again you can see that this belt, which is continuous one actually, I have made in the two figures. Whenever you can see that is this belt, which is again having a motion in this particular direction. Now, you see this is a driven pulley. So, this is not rotating at the very initial stage, this is not rotating. Okay, this cross means this is not rotating. Now, but the belt has got a motion, the belt is giving a motion. So, the basic nature of friction is again suggesting that this particular driven pulley, which is not in motion, will create an opposite in an opposing manner, it will give a friction force, and so the pulley itself gets a friction force in this direction as shown in the figure. Okay, you can see these figures that this gets a friction direction on this side. So, the moment this pulley gets a friction in this direction, this frictional force will create a motion of the pulley in this direction. So, this driven pulley, what has been written in this color, you can see this arrow means that it is creating a motion, and driving pulley means this is actually creating a motion. No, I am sorry, it is already in motion due to a prime mover. So, once again if you see to the entire situation, then this you are having a tension onto the other side, tension onto the other side, and the friction force on the other side. So, obviously again you find this is T2 and T1, and thereby T1 is again is found to be greater than T2. So, we find that in case of whether it is an power drive or it is a drive where the belt at the very beginning is in the state of impending motion and then it creates a motion of the pulley then in both the cases the belt tension directions will be something as discussed over here, and this is the way one can first find out which one should be the tight side and which one should be the slack side. So, I hope that this figure will help you to understand that how to determine the tight side and slack side of a belt drive, whether the drive or the pulley and the belt drive is a driven pulley or a driving pulley. Please remember, driving pulley means the pulley is powered, pulley has got a motion, it gives a motion to the belt. The driven pulley means the belt is in motion and it creates a motion onto the driven pulley. So, driving pulley creates a motion onto the belt and driven pulley means the belt creates a motion onto the pulley. So, this from these ideas you can find out that what are the belt tensions that should be onto the belt drive system. So, one will be tight side and another will be the slack side. Now, let us look into some other aspects of this particular pulley drive. Here you can see that we have selected one drive system having an T1 and T2 belt tensions. That means, what is happening if this is T1 and this T2, the belt will be in motion in this direction, is it correct? So, that means belt will be given a motion in this direction and thereby what will happen? Friction force will be acting onto this belt inner surface in this direction and pulley will get a friction force onto this direction and thus creating a motion of the pulley. So, here we are considering a simple situation where a portion of the belt has been selected and as it is shown in this particular figure. This is in the belt and a segment of the belt is this one, this yellow color is the segment of the belt, and let this segment of the belt is creating an angle or subtending an angle d phi at the center. So, length of this particular belt will be obviously coming out to be r d phi. Now, let us see that what are the forces that is acting onto this small belt segment. Now, you can see that as because this belt has got a movement in this way. So, just at the impending condition, you understand the impending condition means at the point where the belt and the pulley is just having an relative motion. So, under that situation the forces those are acting onto the belt segment are shown onto this particular figure. Please look at the figure. You find that this belt segment is acted upon by a normal force acting from the pulley onto the belt segment, and due to the impending motion the frictional force will be acting onto this direction that has been shown over here, and this is given as mu into dn, and that you know, I need not explain, where the mu you know is the what it is called, the mu is the coefficient of friction. So, mu dn is a frictional force acting onto this one, and here is the centrifugal force due to the motion of the belt. There is a centrifugal force that will be acting onto this belt segment and which has been given as a value Cf, and this value of Cf is computed over here. here you can see the centrifugal force Cf is nothing but m r d phi. What is this r d phi? R d phi is the belt length, and this m is actually what? The mass of the belt of unit cross section for an unit length. That means, what is happening? This is basically mass of a belt of unit cross section, that is the belt mass. Belt mass will be what? This is the belt mass for an 1 meter length, suppose. So, this is what we get as that m, and so r d phi is the length of the belt, the total mass of the belt, and v square by r. So, v square is the peripheral velocity of the pulley. So, that means, v is the, we can call in short as pulley speed. I think I think we should write a better way. I mean, more appropriate will be, it isn't. I think it will be better. Belt velocity. Okay, we can just consider this as a belt velocity, okay, or the pulley surface speed. So, belt velocity. So, this is what we are getting as v square by r. So, entire situation comes out to be m v square into d phi. So, this particular mass of the belt is once again, to have a consistent unit, you know that it is very important. So, this comes out to be mass, means kg per meter, you know. So, this comes out to be what? V square means m square by a square. So, this meter cancels. So, kg meter per second square is equivalent to Newton. So, this is the centrifugal force acting over there is the in this particular direction. Now, this particular belt is having a differential tension at any section, it is given as a T. So, it is incremented onto the other side as T plus dt as shown in this figure. So, because this is an T1, this is T2. So, this side is an higher tension side and this is a lower tension side. Now, so this are the forces acting on to this particular belt segment. So, you know, for equilibrium what we know that the belt should be under the force balance, and here we are defining this direction of the centrifugal force as a normal direction, and this line perpendicular to this one is a tangential direction. So, we know that the equilibrium will suggest the force should be, sum of the force should be equals to 0 in the tangential direction as well as in the normal direction. Now, our duty is just to write the force balance and then find out that what is the ultimate relationship that comes in terms of the belt geometry and the respective tensions that and the centrifugal force etcetera acting onto the belt. So, here if we look into this particular force balance, see this is d phi. So, half of this angle is d phi by 2. So, T, if we take all the force balance in this direction. So, T cos d phi by 2 is due to this force taken care of. Now, this force in this direction is minus, this is positive direction. So, minus T plus dt cos d phi by 2, and the friction force acting in this direction is mu dn, and that summation is equals to 0. And the second one, we see that summation of normal force should be equals to 0. So, which gives us the idea that the centrifugal force in these directions. So, m v square d phi as we have computed over here, m v square d phi plus dn, this is the normal force acting in the same direction, is that is a plus dn, and minus of what? Minus of sin t sin d phi by 2, and this is also minus of t plus dt sin d phi by 2 equals to 0. So, this is the two force balance equations what we find out from this free body diagram of a belt segment. So, let us go to the next slide. You see that once again we are just repeating this particular equations what we have written in the earlier slide. Now, here we have an assumption that this normally this d phi is small. So, we know from the geometry that cos d phi by 2 is can be approximated as 1 and sin d phi by 2 can be approximated as d phi by 2. Now, if you substitute this relationship over here, you can see that you are only having what this term and this term is cancelled and dt cos d phi by 2 is 1. So, you are only having dt and this comes out to be dt and with a minus sign of course, and this comes out to be mu den that equals to 0. So, this yields expression for the normal force this dn as dt by mu, that is a coefficient of friction. And in the next one we have this m v square by d phi remains as it is. This dn is replaced by dt by mu from this equation. So, this is the replacement of dn, and if we look to this expression once again, then what we can see this 2 gives us an idea 2 t of sin d phi by 2. So, that comes out to be how much sin d phi by 2 d phi by 2 2 cancels. So, that simply gives t d phi. Of course, the product of dt and sin d phi by 2 can be very well ignored in this particular equation. So, the simplified form of the equation if we just transpose it, then comes out to be dt by t minus m v square equals to mu into d phi. So, this is the equation what we get from the equilibrium of the force system, and you can see that we are having this one from T2 to T1 is a tension of the belt. So, we integrate it in this limits T2 to T1. So, that comes out to be dt by t minus m v square, and you have seen in this particular pulley what we have drawn earlier. So, this comes out to be your angle of warp, that is an alpha we are considering. So, we consider from the 0 to alpha the entire length from where T2 to T1 has occurred. So, this is 0 to alpha mu d phi. So, preliminary integration gives us that T1 minus m v square equals to e to the power mu alpha. Please note that this is this particular one what has been underlined over here in this equation is one of the very important equation. So, this relates, you can see the tension, the belt material, the belt speed, the angle of the coefficient of friction and the angle of warp, that means how much the angle is in contact with the pulley, that means how much angle the belt is having in contact with the pulley. So, belt speed or the pulley surface speed, tensions in the belts, the belt material property, its mass primarily, and the coefficient of friction and angle of warp. So, everything is included in this same particular equation. So, this is one of the very important one in the calculations of the belt drive. And sometimes you will be finding in your earlier course that this a minus m v square both in the denominator and numerator were not present, which means that if you neglect the centrifugal effect, then the equation comes out to be very well known what you did in your preliminary course may be as T1 by T2 equals to e to the power mu alpha. So, this equation will be utilized in the design of the belts. Now, next we go to the situation. This equation we have already done, and this one, the elastic creep and initial tension. Let us understand what is this one. The presence of friction between pulley and the belt causes a differential tension in the belt, that you have just seen. That means, you are having an T1 and T2 tensions on the both sides of the pulley. Now, what happens, and one side, the due to the tension the belt elongates, while when the belt leaves the pulley, other side it contracts and makes the tension onto the other side to be slack. So, this creates a relative motion between the belt and the pulley surface, which actually is created due to a phenomena which is called an elastic creep. What is this elastic creep? Then if we try to understand, that means what is happening, if you just look into this one, suppose we are having some tension side. Okay. So, this is the well, just one second. So, this is a T1 side and this is a T2. Now, normally what happens that whenever onto from the T1 side, suppose this is being moving. So, when it is going like that, on the higher tension side, the belt has got a tendency to elongate. Now, once it is elongating in this this zone, when just at the entry to the pulley, then what happens? Say it is having a velocity, some velocity, say V1, then this velocity will be the same as the pulley peripheral speed velocity. Now, as it comes over here, then this elongation due to this particular one, what is happening, that in this case, as I told you, there will be a contraction in this zone, and when it leaves this pulley. So, what is happening, that this tension which was higher tension, due to this contraction, what is happening, it loosens the belt on this side, and then it makes this particular tension to be the lower one, and this is the called this particular one is called the elastic creep. One thing I just did not mention, that when it is leaving here, then the velocity is not V1, it is a lower velocity, say something like V2. So, this means this velocity is lower than the velocity at this one. So, this relative motion of the belt is caused due to the thing called the creep, or what we are considering as the elastic creep. Now, on the tight side, the whatever the elongation of the belt is somewhat proportional to the T1. Well, this is T1 minus Ti. What is the Ti? This is called the initial tension. What is this Ti? Once again, this is the initial tension. What is initial tension? If there is a belt drive, then this is the belt. So, initial tension Ti, this is very much required, otherwise you cannot keep the belt in position at the very beginning, and you have to put some amount of initial tension, so that a friction grip is there at the initiation. Now, the moment it starts moving, then this initial tension changes to either T1 or T2 depending upon the direction of the belt motion or the pulley motion, whichever you consider, and considering the fact by which we decided which one should be higher tension side and lower tension side in the earlier slide. Anyway, the idea is that this initial tension do not keeps the same, it is only same on both the sides when the pulley is stationary. So, tensions on the both the sides of the belt are equals to T I. When the motion sets, then one will be T 1, other will be T 2. Now, this elongation on the tight side will be proportional to, as I told you, it is proportional to T 1 minus T I, and on the slack side the contraction will be proportional to T I minus T 2. So, if the elongation equals to contraction, that means if the belt rate remaining same, we can see very easily that T initial tension is given, this is given by T 1 plus T 2 divided by 2. Now, the interesting fact is that in this case, suppose you go on imposing more and more initial tension onto the belt system, then what will happen? That in this case the T 1 will go on increasing and at the same time T 2 will go on decreasing. At one time it can happen that T 2 comes out to be equals to 0, and that is one condition where you will be having a maximum amount of power transmission. However, this initial tension is very important. So, just one second, just before coming to that one, if the T 2 comes out to be 0, then you can find out that this particular T 1 will come out to be something as twice of the initial tension. So, this is 0 means T 1 comes out to be twice T I. So, this is one situation where you will be finding out the power transmissions to be maximum. Now, coming back to the point whatever I was just trying to tell you, that initial tension is very important. Just by increasing the initial tension, you can increasing the power transmission capacity. At the same time, the initial tensions are responsible for the calculations of the bearing loads, ultimately which will be onto which these initial tension situations will come into picture. So, in general what happens that some sort of initial tensions are set onto the belt for the better power transmissions and also for the grippings, but anyway the initial tension can be computed from the fact from the equation what just has been shown over here as T I equals to T 1 plus T 2 by 2. So, this is what we talk about the elastic creep, the phenomena of how the friction is actually responsible to create this type of motions in the belts, set motions into the belts, and the phenomena as I told you is the elastic creep is responsible for that. Now, other two important situation that comes into picture are velocity ratio. Now, this velocity ratio or sometimes it is called also the transmission ratio, this is the NL by NS, means if it is NL, the N is a pulley speed of rotation and NS is the smaller one as you understand, and NL is for the larger pulley. So, that comes out to be in the form of these two values ds plus t dl by 2. Understand the diameter of the smaller pulley plus this is the belt thickness, T is the belt thickness, and this particular one is 1 minus S, and what is this S? The S is called the belt slip. This is one situation that normally the all belt there will be always certain amount of slippage between the belt and the pulley. It will be more prominent where the angle of wrap is small, and all drives will have a slip, and thereby 100% transmission is not possible. Well, in this case the type of belts we will be telling later on that the efficiency of the drives depend upon this slip for both cases of the flat as well as the V belt drives. Normally the flat belt drives will have a little more higher efficiency compared to what we will be getting in case of a V belt drive. However, the V belt drive do have a little more power transmission capacity compared to the flat belt drives, because of the groups create some additional frictional forces. Now, in this case if we understand, then if we understand this particular idea, then this velocity ratio is N L by N S equals to d by t plus d L into 1 minus S. Normally, you will be seeing that 3%, well, it is not a final one, but around 3% slip is something what we can consider to be a standard value. So, if we consider a 3% slip, that means it will be actually 0.03. So, you can understand 1 minus 0.03, that is 0.97 will be coming out to be the value of 1 minus S. So, thereby certain amount of velocity ratio is lost due to this particular slip, because we know that N1 NL into DL is NS into DS. So, this is a very standard formula, but which gets lost due to this particular belt slip. Now, the expression for power transmission is very simple. Power is T1 minus T2 into the belt velocity V. So, once again you know T is in Newton, okay, multiplied by V is meters per second. So, Newton meter per second is watt. So, that is the reason power is watt, but a convenient way of putting the power is kilowatt, thereby a factor of 10 to the power 3 sometimes can be utilized. But anyway, let us put down the expression in this form, and corresponding units should be in SI as I have told, but only thing this multiplication factors will be considered depending upon the design problem. But anyway, the power is always in watt in SI unit, and this kilowatt is simply a higher unit, means is multiplied by 10 to the power 3. Now, we have considered all the basic aspects of a belt drive. Now, just once again, what is a belt drive? Basic things, that is a cross open belt drive, one situation, cross belt drive, you know. Then the how we determine the belt tensions, that is also clear to you. Then we have derived once the important, very important equations of T1 minus mv square by T2 minus mv square equals e to the power mu alpha, and the initial tension expression is also T1 plus T2 by 2, velocity ratio as is shown over here, and the power transmission is also T1 minus T2 into V. And normally what happens that these terms what has just been explained, okay, remains the same for type of drives what we will be considering, that is a belt drive, sorry, the flat belt drive or the V belt drive. Some minor changes will come into picture that we will be indicating after certain time. So, if we consider the fact, then we see that we start our discussion on the flat belt drives. So, in this case the flat belt drives is something like this, means the belts have just a configuration like this. This is a longitudinal. Okay. So, this is the what we called as a flat belt, and drives utilizing such belts are called flat belt drives. Now, one thing you should know that in this case of the flat belt drives, in the market you will be getting the flat belts of different weight, different thickness, different material in form of big coils. So, just like the way you purchase some length of thread, if you tying thread or the wire from the market, how you go, just you give me 2 meters of wire or 2 meters of threads like that. In the belt, flat belt drive also, one has to decide upon the belt length from the calculation or the equations that just what you have seen, and from there once he or she finalizes the what should be the length of the belt, that much of the length of the belt of a given specification can be cut and joined together to form a belt. So, one of the situation that comes into picture is that this belts requires a joint somewhere. Okay. So, much design aspect or design considerations should be put over here in this joint, means one should be careful that the joint should be made so that it is very near to a jointless case, means this should be cemented in a very nice way. Otherwise, this is a location from where the belt normally gets snapped, or if it is fixed up with some sort of clips and other things, this is a source where the noise also comes into picture whenever the belt drives run. So, what people do that they can use a cemented belt from the factory itself, or with care one can join these belts with various clip systems that are available in the market. Normally, the flat belt drives do not have any limitation of center distances. It can go as long as possible. As a matter of fact, the belt conveyors are one of the situations where really you are having a very long distances, but of course, the speeds are not high, because if you are operating at a long center distances and also very high speeds, then what will happen that the centrifugal force will be acting largely onto the flat belts. So, a judicious choice of the center distance is required in cases of flat belt drive. That means, it can, although it can take up a large distance, but the care should be taken that it should not be very large, or too, the reasons just I have told you. Now, in the case of the belt materials, what we get are the leather belt, that is oak tanned or chrome tanned, rubber, canvas or cotton dag impregnated with rubber. Let me just clear this one, impregnated with rubber. Then plastics are this one, the thin plastic sheets with rubber layer are being used as in belts. Now, these belts one can see is that can be looked upon that this is one layer and this is another layer, this is another layer. Like that also one can make or build up a belt thickness. Now, this one or is called the word ply, that is, a number of layers is what we understand by the ply. The last of the belts are the canvas or woven cotton ducks. So, these are the most used belt materials, that is the leather, rubber, plastic and the fabric. So, this belt materials are to be chosen depending upon the use and the applications. Leather, oak tanned belt and the rubber belts are sometimes are very are the belts which are most commonly used, but the plastic belts have a very good strength, almost twice the strength of a leather belt. Well, we have just discussed about the belt materials. You can have more knowledge of the belt materials from the handbooks, and with this we complete today's lecture, and we will talk about these flat belt drives again in the next lecture. Thank you. Good day. Today we continue our discussions on the belt drives. This is lecture number 31. Now, in the last class we started with the belt drives. So, just to recapitulate very quickly, we started with the belt material. Now, normally for the belt drives, leather, rubber, plastic and fabric are the materials which are most commonly used for the manufacturing of the belts. Now, in the leather belt material, you are having, you can see the oak tanned and the chrome tanned type of leathers are available. In the rubber, basically what happens, a canvas or cotton duck impregnated with rubber. This is the construction of the rubber belts. Plastic belts, as it was told, it consists of a thin plastic sheet with a rubber layer, and which could be having more number